Hi, everyone. Welcome to the panel for Simple Robots That Win, featuring Mike Corsetto, Adam Hurd, Tyler Holtzman, and Zack Moore. My name is Austin Haddox. I've been in FIRST for 8 years, started as a student on 2085, and mentored them for a couple years, and then have started mentoring 1678, where I focus mainly on strategy, scouting, and mechanical. I'm studying statistics and economics at UC Davis and work as a senior data analyst at North Bay School Insurance Authority.
Hi, I'm Mike Corsetto. I'm the lead technical mentor for 1678. I've been mentoring since 2008. Was formerly on Team 114 as a student, and I'm a Woody Flowers finalist award winner at the 2016 SAC Regional.
Adam Hurd, been doing this forever. Bulk of that time was as the lead mentor of 973 for 12 years. Been working with 284 for, I guess, a year and a half now, and then also just signed on with 2135, and will be splitting my time between those two teams going forward.
Hey guys, my name's Tyler Holtzman. I'm the lead design mentor for Team 2056, and I've been involved with that team since 2007 when we started. Before that, I was a student on 1114. My professional career, I'm a senior design engineer. I build robots. It's a lot of fun. And 2010 Woody Flowers finalist award winner.
Hi guys, I'm Zack Moore. I'm currently a design mentor on Team 503. I was an alumni off of that team, and I also did 3 years, a little over 3 years as a mentor with Team 314. Currently, I'm a systems optimization engineer at Ford Motor Company, and I'm happy to be here with all these much more qualified mentors than I, but hopefully I can get a good perspective on moving from a small team to a much larger team in 314 to 503.
Awesome. So let's start off the conversation with what is a simple robot? So, hey, Tyler, can you start with that?
A simple robot is, well, it's a robot that's mechanically simple to build. It's something that, the average team in FIRST should be able to do, and it's something that is fundamentally not complicated, not difficult to build. It shouldn't be something that, has multiple mechanisms with multiple degrees of freedom. It should be something that's, very simple. So some, great examples of simple robots over the years are the sort of classic architecture of the 330 robot, where you have a 6-wheel drive robot and a shoulder joint and an arm with something on the end of it that, manipulates the game piece. So simple robot is quite literally just a robot that has the fewest degrees of freedom possible to achieve your goal.
I think to add on, Ty has so much experience building like simple, effective robots. One other thing that comes to mind for me is on the design side, reducing the number of tasks that you choose for the robot to accomplish is another element to simple design. So it's not just reducing the degrees of freedom to accomplish specific tasks, but actually, I think a trend that we see on effective simple robots is they're purposely not accomplishing certain aspects of the game. And that could be like small iterations on aspects of the game, or it could be completely ignoring certain aspects of the game in order to simplify the overall design.
Yeah, absolutely. I would say it's whatever architecture lets your team finish the robot on a schedule that makes sense, which really should be like week 4 of build season, spending the exact amount of resource points or less that your team has. So if your team has 100 arbitrary resource points, you're doing a robot that costs 100 or less and not 101 or anything higher than that. So that line's going to be a little different team to team, but I think it's always simpler than people would assume in general, for sure.
Mm-hmm.
And that finishing early concept is what allows you to get those consistent drive practices and reliability within the mechanisms that you've developed over your build season.
Yeah, absolutely. Have you guys ever built something that's too simple? And how do you know that something is simple enough? Adam, can you kick us off?
I definitely don't feel we've ever built something that's too simple, and I would wager maybe 5 teams in any given year can really honestly make that point, if that. Like, if you're not losing in Einstein finals with a perfect robot that you don't regret anything on by just small margins from capabilities you didn't have, you probably didn't go too simple. At every level of play below them, I can't imagine teams are missing out from being too simple. How do you know if it's simple enough for you? Geez. So your presentation earlier today that kind of touches on that, but that's a tough one. It kind of takes years of self-reflection and looking at how last season went, and assessing it with your resources, seeing what's changed in the last year, and there's a lot to that question.
Yeah, for sure. I definitely I agree with Adam there. How do we know if it's simple for us? That's a question that takes years of experience. Teams really need to honestly evaluate what their resources are from a design standpoint, from a fabrication standpoint, and understand what their capabilities really are, and have a really good handle of that when they come up with an architecture for their robots. And have we ever built anything too simple? Not on 2056, we haven't. And we built some pretty simple robots.
I think Adam mentioned it earlier. It's really hard to gauge this, and it takes introspection. I think like Father Time is a very objective judge of this, and the amount of time it takes to complete your robot is going to be I think that's an effective barometer as to whether or not you're building simple enough. Because Adam mentioned that 4-week time span earlier. That really is like the gold standard of time spans you want to be hitting when you build your robot. And I know, for example, this last year with no bag, it was so tempting to build more complicated because you had more time. And that really bit us, especially 1678. We did not manage our time well, and we built too complicated. And we did not hold ourselves to that 4-week time window. And it showed in our inconsistent results in the field that year. Like we ranked lower at the 2020 regional that we went to than we have in the last like 4 or 5 years. So I think that was a good wake-up call to we were not following our own simple design principles, and we did not have our robot done by week 4.
So we talked a lot about these limits. How can teams try to find out what their limits are and what the best use of their own resources are? Hey, Zach, do you want to take this one?
Sure. So off-season projects are generally where we start as determining what our resource level is. Generally, if we have students that want to do off-season projects, that correlates directly to what kind of students we're going to have during the build season. And so we can kind of use those to gauge where we're going to be. And we've done, in my experience, I've had anywhere between 6 students to 100 students on a team, and it dramatically changes the way that you approach your build season, and changes kind of what you want to accomplish.
I'll tweak the question. You go, Ty.
I really agree with what Zach said. The whole off-season thing is a great way to figure out what your capabilities are, and it's a good time to explore maybe what your limits are and try to do something that might be beyond what or at the very limit of what your team is really capable of. In season is not really the time to be experimenting with new stuff. Like if you haven't done a swerve driver before, you probably shouldn't build one for the first time in season. And that's the same thing goes for a number of other more advanced mechanism types. So yeah, off season, great place to figure out what your limits are if you don't have the sort of experience up front to know what they are to begin with. Like on our team, we don't do a lot of off-season stuff anymore. But when I was like a young 20-something kid, I used to build a couple robots every year in the off-season. Not so much anymore because I'm grown up and have a real job. But back in the day, we used to build a lot of stuff in the off season to sort of push those boundaries and figure out what we were really capable of.
So when you are deciding your limits, I would say pretty universally aim a little lower than maybe you initially assessed, which sounds terrible. But like we were talking about earlier, there's very few cases of people that actually went too simple. And if you do actually make that mistake, which I think is really unlikely, if you go too simple in season, all of the resources of your team are super free to pivot and start adding stuff that you might have missed. Whereas if you overshoot and all of your stuff is kind of halfway done, you're really playing from behind and it's hard to finish. It can be really hard to de-scope in season as well and just take one thing off the robot if your robot was pretty cohesive and integrated. And then also, try to find the simplicity or buddy or mentor if you can. So, I don't know that I've shared this with the world ever, but Mike and Ty, among a couple other people, I email them Sunday at kickoff every year. And I'm like, here's what we're making, in full detail. This is our whole plan. Does this make sense? Is this crazy? And I've had a couple times where I felt it might have been too simple. And then Ty makes a robot that's 10% simpler than what I emailed them. So I'm sure there's some local team or someone that would be willing to do that for you. Because usually people are really willing to criticize someone else's ideas or give them help or that sort of thing. So I would try to find someone you can reach out to and just gut check your whole robot concept, a couple days after kickoff. Take that feedback, present it to your whole team, discuss it, and hopefully act on that information.
Agree with a lot of what you just said, Adam. We do a lot of internal review on that, and then we also give it out to a couple other teams, and they really gut check that. I'm also a fan of consecutive designing and building for smaller resource teams than I am parallel designing and building, meaning that in the first week or so, we try and have our drive base done, and after that, every space claim, and then we focus on one priority at a time. So if, let's say we have a ball game, we normally try and shoot to have the drive base done, Wednesday through Saturday of week 1, but the next priority is the intake, and everything else on the robot has a space claim. And once our 6 to 10 students are good with the intake being done, then we move down the path, and next thing would be your indexer and then your shooter. And that's just based on the fact that to play the game, you have to be able to pick up the game object. And before that, you have to be able to drive. And so if you spread your resources too thin, then it's hard to make that up on the back end.
Yeah. So how can teams use those focuses to figure out what parts of the games they can focus on? So specialization is a really good example of that. So how do teams know what in the game they can cut out of their plan to keep the robot simple?
Yeah, Austin, I was thinking one idea that came to mind when we were looking at this question before our panel, making sure that the challenge that you're tackling doesn't have a lot of scoring prerequisites. So I think one good example of this is the color wheel from this year. I know it was kind of a gimmicky challenge that was added, but you needed to score, I think it was 29 balls before the color wheel ever came into play. And the number of matches where 29 power cells were actually scored was very small. And so I think as a team, when you're evaluating what challenges do we actually need to do, I think a lot of teams looked at the color wheel and they said, oh, it's just a color wheel. It's super simple. We can put 3 kids on the color wheel mechanism and the rest of the students can be working on something else. But that color wheel mechanism was never going to get used by that team. I mean, there were very few number of teams that ever actually spun the wheel to score points. So that's one thing that came to mind is, does that scoring element that you're trying to accomplish have a prerequisite scoring element to it? And if it does, it probably is not the lane that you want to be in.
I would say, unless you're already a 95 percentile team, to way oversimplify this, you look at the parts of the game where 3 robots can actually contribute. And then to oversimplify it some more, for a good amount of time, that's usually been endgame. If you're only going to be able to do one thing and you want to get into a limbs with that one thing, it's probably endgame. There are some exceptions, 2018 was really a rough year to try to use this logic on. But try to figure out what are those top teams going to want to pick in that second round of the draft, and then usually that'll still be valuable as you get better and better.
Yeah, absolutely. Like, we always start looking at the points that are available for scoring and figure out is the best bang for your buck. So what gets you the most points for the least amount of effort, which, to Adam's point, is almost always end game. So the very first thing that every robot should have been able to do in 2020 is drive around and hang off the bar. That's all. Well, those are the first two things. You must do those two things. If you do nothing else, do those two things. And that would have gotten robots picked in the elimination rounds at every event. Like, there's no robot that can do those two things that would not have gotten picked or been an alliance captain, at a district event. I mean, maybe not by the championship, but those should be the first, two things on your list. And then you look at, acquiring balls and scoring balls and things after that. Reward versus effort, and then, make your priority list based on that.
Absolutely.
One other thing that came to mind, Ty. Oh, sorry. I had one other thing too. Ty mentioned the end game, and Adam mentioned that too. Totally true. I think the next thing that comes up past the end game is what you do with your preloaded game elements, if you have any. I think that's always like the next best thing. I remember like thinking to myself, I think it was in 2013, like teams that could just reliably score their preloaded discs, like consistently, would be some of the top scorers at the event, right? They'd score their preload discs, maybe struggle to score some more and then hang, and they'd be scoring above the average number of points in a match. So, and then when you think about how you're going to fulfill one of those roles on a 3-team alliance, being able to score your preloads and then score in the end game are huge. And focusing on those two things seems to make a ton of sense for trying to build simply.
Absolutely. So what are some specific examples that you guys have specialized, and how did you guys come to those conclusions? So I know for Adam Hurd specifically, in 2019, you guys decided to not go to the highest level of the rocket. How did you come to that decision when other equivalent teams thought of it as a necessity?
There were kind of two routes there. So for context, like 2 weeks before kickoff, I signed a job offer, and I was going to be moving halfway through season. So we kind of entered season, stressed and constrained. Unfortunately, it didn't happen 3-4 months prior where we could have had like a better transition plan. So actually, kickoff day, I was really tempted to go low at that point because in elims, there was no rocket bonus. So it was just bulk game pieces you were trying to score. Couldn't quite commit to it that day, so we made a tall robot. And it was probably about week 5, week 6 with us with us competing at a week 1 regional. And it was a little tough for the team to practice in my absence. You got to do the rocket game plan. You got to have your limbs game plan where you're not doing the rocket. And there's just a bunch of different competing things. And I felt, well, we can probably get away with this. So, when you really zoom out, it's a great data point. When you zoom in, it's not as clean because we waited too long to make the decision. But that was driven off of, in elims, you don't need those upper points. 2910 might be a better example of this case because they committed from day one and had a higher point average than we did. They were absolutely incredible. I'd be curious to hear some of the other panelists' thoughts on the same question.
The example I go to, it's another like world championship example is our 2015 robot where we were a 5-stack builder, and I think pretty much everyone else at the high level was a 6-stack builder. But we specifically built for 5 stacks, knowing that if we had the can advantage, we could win the match even if we weren't building to 6. And so we kind of understood that it was going to come down to the can. Granted, we totally missed on how you were going to win the can race because our original design for like 6 weeks was a 4-wide, massive, like 30-pound wing that was coming down on the cans, and that was not competitive, right? You look at what happened at the playoffs, and that was not the way the game played out. But because we built our robot with the can race being such an important element of the design, we had a massive, like 15-inch deep area of our robot to put these huge crossbow-like mechanisms on that just destroyed the cans every match. And we wouldn't have been able to do that if we were devoting more of our robot to making 6 stacks. And so I think that was an area where maybe we didn't understand the exact mechanism that was going to be effective for that year, but we understood what our priorities were supposed to be, and we committed the space and the weight to the can race, even if we didn't know exactly what it was going to look like at the time until the season developed and we figured out, oh, we got to do it like grabbing 2 and not 4. I think that's probably our team's best example of specifically eliminating 6 stacks in favor of 5 stacks because we understood it would be more competitive in the win-loss format in the finals.
Yeah, and another
I don't
example of.
Sorry, go ahead.
Oops, sorry. And
Go ahead,
another
Zach.
example of kind of finding out we should have gone a little simpler a lot sooner is our 2018 robot on 314 was intended to be a scale bot. And then roughly week 4 of build, we were having a lot of troubles hitting the priorities that we were originally trying to hit. And the students honestly just stressed out and weren't having fun with it. And that's kind of the main component of first, is like you're supposed to be having fun. And so we reevaluated our priorities at that set point and ended up scrapping everything to make a little switch bot and then developing that later on in the game, because our priorities first were to hit the switch and then the scale, and we couldn't even hit the switch with our elevator. So ended up working out and having a lot more fun later down the line with it.
Yeah, that was a good little robot. Yeah, for us, I can't really think of a time where I really regret not building something simpler. Like in recent years, our robots have all been fairly simple to begin with. There was a couple times where we looked at doing more complicated things. 2018, for example, we strongly discussed lifting 2 partners beside us when we went to climb, and the layout would have been exactly the same way that 1678 did it. But when we looked at it from a 10,000 foot perspective above, we started assigning some kind of budget weights of how many motors and how much weight can we devote to each of these mechanisms, and there wasn't anything left for it. So we ruled that out fairly early, that we weren't going to try to lift 2 partners with us, when the previous year we had lifted teams with us to hang off the tower. Scale. So we ruled that out fairly early. We, however, did not leave enough room for a way to climb to level 3 with a partner, and I do regret that. But that was more just the architecture of that robot. So yeah, kind of sucks.
Yeah. So just a reminder to everyone watching, if you have any questions, post in the chat, and I'll ask it to our panelists. So as we are having a similar game to the 2020 season coming up, do we see high goal being a necessity to specialize for teams that plan on scoring game pieces? Or do you see low goal being a realistic use of team's time when designing a simple robot? Mike, can you kick us off?
Yeah, I mean, hard to know what 2021 is going to look like with this game. I'll say that for starters. One thing that always intrigued me about the low goal is how much of a slam dunk it helps in getting towards the ranking point. Now, what kind of shook out this last year is it became pretty clear that it was going to be really hard to get the 49 fuel power cell ranking point, and so I'm not really sure if that really bears out, or if it really just comes down to points at that point. The thing I will say is it seems like the 2-point goal is a lot easier to hit than the 3-point goal, and if you make some assumptions that you're not going to aim for the 3-point goal, you can shoot from different angles, maybe from nose up against the wall, that could make your job of scoring in the 2-point goal a whole lot easier. You could maybe even do like a full width shooter, so you don't even have to do any indexing. There's a lot of options that start to come up when you ignore the 3-point goal. But I think the 1-point goal, even for simple robots, I think the Everybot was a great example of scoring on the 1-point goal, but because the ranking point was super hard to get regardless, it made the allure of just getting more balls in the goal a little less appealing, I guess.
Yeah,
But then there's also the trade-off of, oh, sorry, go Ty.
Yeah, for me, I think teams got to really evaluate what their season goals are and what their resources are, because I think number one, you have to hang first before you even touch a ball. You have to hang first. You have to hang reliably every single match, 100% before you even touch a ball. Then after that, you can think about shooting balls. The 1-point goal, depending on where you're playing, you're not getting a whole lot of points for the amount of effort that you're putting in. You're building a accumulator, lifter, and ball deposition thing. So like the Everybot. But for a lot of teams, that's still a lot of resources to sink into a mechanism, when you could maybe be devoting your time to playing defense, which in some events may be more valuable than the amount of points you're going to score from the low goal. But from a qual standpoint, you're not going to play defense every match because you're not going to play good teams every match. So I think you really got to look at what events you're going to and what your season goals are. And if you still have resources left over after hanging 100% of the time, then you start, looking at balls. And if you are going to look at balls, you probably want to be, starting with the 2-point goal where you actually get some payback for your reward versus the 1-point goal, which is, just as much effort and half as many points. Yeah, a 2-point goal shooter is not out of the realm of possibility for teams with low resources. So yeah, I would be leaning towards the high goal, certainly. Maybe not the 3-point goal, but the 2-point goal for sure.
Yeah, you just want to be clear about what your goals are, and the ranking points in some years are directly in line with what you would want to do to win an eliminations match, but not every year. So like this year, doing the 1-point goal might be a great qual strategy to excite your partners 3 or 4 times when they have enough ability to finish it with you, but might not get you picked for limbs because of the amount of balls you have to score to even make a meaningful impact. And at any high level of play, there's going to be a limited amount of balls out there. You don't get to just pick up 30 1-point balls and score them. So you're going to be better off scoring, 12 to 15 2-pointers for sure. And you'll actually be able to get 12 to 15 balls.
And when looking at shooting at that 2-point goal, the batter shot where you're pressed right up against the goal is probably one of the easiest and best ways to try and do that, just because it's a fixed hood angle and it's a definite spot for your drivers to line up to every time. And you might get lucky, have a couple 3-pointers.
Yeah, and I really liked Mike's suggestion there of going 2 or 3 balls wide on a robot that only shoots point blank. I don't know that we saw many or any teams doing that this year, but I think it would be a great way to give up on the 3-point goal, give up on indexing, and just put balls through quickly right into that point blank shot.
Yeah, absolutely. So what are your guys' thoughts on what resources teams should go to for what kind of successful designs have been used in the past? Where, or maybe some ideas on what they should focus on from year to year. Where can they find this information, and how can they find that? What are some resources that they can best use season to season? Hey, Tyler, can you kick us off?
Alan Gregory's team has some great resources for CAD examples. He's got like a whole library of examples of CAD robots built up and examples of mechanisms. Spectrum. I don't have the link off the top of my head, but it's a great resource for people who are looking to, learn some robot history and see some examples of robots who haven't, been around for a decade or two. So, experience is one. Asking around is one, but Chief Delphi is another really good one. But unless you really know what you're looking for, it's hard to find, really good examples of simple robots. Historically, teams like Beachbots are my favorite example. They always built amazing robots that were simple. They were consistently a world-class team with the most basic resources. Like, people thought they had huge teams of machine shops and engineers behind them, but it was really just a small group of really good guys who really knew what they were doing. Failing that, I know we've built some pretty simple robots over the years. 973's built some pretty simple robots over the years.
Mm-hmm.
I know lots of bad examples.
We can go through those too.
That would be fun. Oh, man. So our rookie year, can we do a little story time aside here?
Let's do it.
Our rookie year, 2007, we built literally the simplest possible robot you could imagine. It was a drive base with an arm, pinch claw on the end of it. And we just would drive up, we'd pinch the tube, lift them up, and put them on the rack. And that's all the robot was. Super basic. We had no outside fabrication. We had no, elaborate resources that we had now. Built a thing in the shop in, a couple of weeks. It was no big deal. And we had some good success that season. We went to IRI, and we got picked by Wild Stang. Wild Stang was literally the antithesis of our robot. Back in the day, Raul Oliveira used to be the field coach for Wild Stang. Incredible mechanical designer, like just utterly brilliant. Man was insane, but incredible designer. And they had this robot that was, it worked incredibly well. We won the tournament with them. I was super happy to play with them, but it was so incredibly complicated. So they had a shoulder joint, they had a wrist, an elbow joint, they had a rotary joint in the forearm, plus a pinchy claw, and the whole mechanism would flop down so that another robot could drive on top of them. Oh, and they had a swerve drive too. So it was like this incredibly complicated machine that, it actually worked remarkably well. But we're going out for the IRI finals, and the two of our robots are like side by side beside each other, and I'm like, huh? What are we doing wrong here? So it was interesting to see the two of them side by side and see one that was literally built as complicated as you could make it, and the other that was built so, incredibly simple. I don't have really anything against complicated robots, and when they're pulled off well, it's really cool to see. But more often than not, they're not pulled off well. So, yeah, the good old days. I used to joke with Raul. He used to say he'd make the robot as complicated as possible to inspire the students. And then I turned and said, I make the robot as simple as possible to inspire the students. So, yeah, good times. I miss Raul.
Good stuff. Austin, you mentioned what resources you can use. I think we hammer this in the strategic design talk we just gave a couple hours ago, but the Kitbot is like the number one simple robot resource that you can use on your team. Like, for goodness sake, that thing has been built thousands of times by thousands of different teams in FRC, has seen hundreds of thousands of drive hours, if not into the millions at this point, right? It is a proven mechanism that comes as a part of the standard rookie kit, and for all the teams that don't opt out of it. If I could point to one resource that can make a team build a simple robot, like the Kitbot's probably step one, or step zero, and then go from there to figure out what game challenges you're gonna focus on. But yeah, that's the first thing to do is build the Kitbot drivetrain.
To piggyback on that, you hear a lot of pushback from teams when you suggest it that great teams don't run the Kitbot, and that's kind of true. But if you squint, almost all of I'd say probably 80% of the best 1114 and 2056 robots, they just made their own kit drive essentially. Like it's the same plate setup, same wheel style. Like the details are a little different, and maybe Ty spending extra time to make something he could buy, but the performance is the same. You can put traction wheels on a kit bot, you can put shifters on a kit bot. Anything that you might think is deficient there is something you can buy and slap on, and you're getting the same drivetrains that these two teams have won. Geez, I don't know, 80 plus events total and a couple world championships, just done incredibly well with.
0, actually.
That was 2 teams together, so.
Yeah, for us, like we don't use the kit drivetrain because we have really strong outside fabrication resources. For those of you who can't see, I actually have a kit drivetrain in my office for just goofing around with. Yeah, the only reason we don't use it is because we have really strong outside fabrication resources, and at this point we can knock out a drivetrain in a couple hours and send it out for fabrication. It's really not a big deal, and then we can integrate a lot of other cool stuff into it to make the overall robot flow better and have better integration and have mounting for electronics and compressor, and maybe we have to do something weird with our battery. We had really wacky battery mounting this year. Nobody ever got to see it because the robot never made the field, but you actually had to take the front bumper off and insert the battery through the front plate of the robot because of the position of a bunch of mechanisms around it. And we couldn't have done that if we had used the kitbot. But yeah, kitbot's great chassis. It's robust. It's simple. It's done. You don't have to do anything. Just put the thing together. It's a huge amount of resources that you could not devote to, that you could devote to something more useful like hanging or your end game or your manipulator, that you don't have to worry about trying to make something that the majority of teams will just do worse than the kitbot was in the first place.
Mm-hmm. To expand on that some, have you guys ever crossed a team off your pick list because they have a kitbot?
No, we've crossed lots off because they had Buchanan wheels.
Yep.
But never because of a kitbot.
Mm-hmm.
The one step up from that is when you start expanding your team's resources, I wouldn't look far beyond the Versa chassis system either. Like after you can manage the kitbot and you have some time in the off season to test a new drivetrain, if you want to do that, then I wouldn't go much further than the kits that Vex has for Versa chassis, because the lines are scribed at every half inch, and we on 314 used to build our drivetrains with that and the bearing blocks, and used a step drill bit to drill the bearing holes, and it was super easy.
Yeah, Vex Pro products really number one design build kit. We're all Vex teams here, but big props to our sponsors, Vex Pro. Gotta love them.
Yeah, absolutely. So I think I can speak for a lot of people that we use 2056's autos as an example of not only what we're going to face, but what we can do during the season. How can teams plan, or how does a team's plan for what they're going to do in auto affect what their overall design goals are going to be?
Well, first off, you got to look at, is what you're going to do in auto worth enough points to develop the architecture around autonomous? And some years you can take a commanding lead in autonomous and then just ride that out to the end of the match. Other years, the autonomous is not so important. The best example I can think of from recent history was Poofs in 2014. They built this double ball gripper to do 3 balls in auto, and they were going to do 3 balls in auto every time, no matter who they played with. And they won Einstein. They were freaking amazing. Another amazingly simple robot. Super, super simple, super well executed. Yeah, another good example is 2017. We had those hoppers with the balls in them. So the scoring was super dumb that year, and you had to score all of your balls before the auto period ended. And the counter took like an hour to count the balls. So if you wanted balls to count, you had to shoot them really early in the autonomous period. So what some teams planned to do was just drive to the hopper and then shoot from the hopper like over their shoulder. Except the field was also asymmetrical, so like if you were on the blue side, it was one way, and if you were on the red side, it was the other way. So it was like super annoying for people that are incapable of building asymmetrical robots, like I am. But yeah, we mistakenly didn't realize how long it took the counter to count the balls, and our plan was to drive there, hit the hopper, accumulate a bunch of balls, then turn around and drive back to the goal and shoot them. And we did that at our first event. And we usually shot like 30 or 40 balls, except like 10 of them counted for auto, and the other however many we scored counted for the teleop period. So we were leaving tons of points on the floor. And that was a really good example of where, had we built the robot more to do auto, like with a turret or with our shooter that could shoot all the way from the hopper instead of driving up close to the goal, we would have been way better off. Which actually led us to one of the biggest like mid-season rebuilds we've ever done, where we changed the shooter to shoot from range rather than from up close. But that's at the side. But yeah, you got to look at the game. Yeah, sorry. Go up.
Yeah. Go Adam.
For the majority of teams, 90 percentile and below, figure out as best you can what the big, obvious elite team auto is going to be, and then don't do that. Like, do something complementary to that. And if you are going to do a failed attempt at that, don't be the team that's like, I have one auto, it's hard-coded, can't turn it off, sorry, got to run it in the match. So, even something as simple as already having an auto written that like just spits balls out at an arbitrary amount of time that you can control is huge when these other teams are coming around and doing pre-match planning with you, and you're like, hey, I can't shoot balls in auto, but I can spit them out at 5 seconds, 8 seconds, 11 seconds. You tell me what you want, and then I'll drive 5 feet. That adds value in those matches, and it also leaves an incredible impression with the teams you're playing with, that you're a team that understands what's going on and is ready to play in a limbs and will do what you need there. And then, keep incrementing as it gets better. So like, I was visiting LA North with 973 this year. We played with Mike. I think our third shot 3 balls and got out of the way. And they were the 24th team at the event, or 5 balls, whatever you could preload this year. And it's like, you didn't need much to do that. You didn't need any fancy drive code or that kind of stuff. You turn your shooter on, you shoot them, you get out of the way. Maybe they did it at 12 seconds, not interfere. I don't even remember. But it was just written to be complementary to the type of autos that Mike and 973 were bringing.
Yeah, for sure.
And another...
Yeah, if I can, just to talk about autos for a second. Yeah, the teams that come with one auto that's hard-coded is so incredibly difficult to work with. On our team, we've had some pretty good autos over the years. But when we start writing autos, the first thing we do is we write an auto that crosses the line with no sensors. So if all hell breaks loose on the robot, we lose the sensors, we lose, whatever, we can drive across the line. And we have that auto that, stays with us for the entire year. We also have the ability to delay any of our autos by an arbitrary amount of time so that we can sit there for 2 seconds and then cross the line, or then cross whatever auto we do. And not only that, but have the ability to change your autos without having to download code to the robot. I cannot remember the amount of times where we've been walking out to a match and you've got some student that's sweating bullets with a laptop that's connected to a robot, and he's like, I'm trying to get code on the robot and I can't get it. And then you go and you line up for the match, and the FTA comes by and goes, well, no code. I guess we're bypassing you. Don't download code 5 seconds before the match while you're on your way to the field. Have those things prepared ahead of time. I can't stress this enough. And the ability to run multiple autos is super easy. You don't need an elaborate dashboard and smart dashboard or whatever they're calling it these days. We use the Logitech gamepads. These ones. They got 12 buttons on them. They're numbered. And the way our autos work is, if you want to run auto 1 while the robot's disabled, press button number 1, and it'll run auto number 1 the next time you do it. You want to run auto 2, press button number 2. And it's literally that simple. There's no elaborate drop-down menus and user interface on the dashboard. And if you want to delay, you hold button number 1 and you move the joystick up, and it'll delay by up to 15 seconds. You leave it in the middle, it's 0. And it's literally that simple to choose different autos on the fly. It doesn't need to be, some elaborate control structure. It should be really simple to be able to change these things on the fly. That's my rant on auto modes for the day.
I think the key with that too, Ty, that you're getting at there is it's way more competitively advantageous to have 4 to 5 different simple auto mode options than it is to spend your whole programmer's time on trying to hit that 8-ball auto that's going to take you 3 weeks to tune, right? Focus on, like you said, start with the basic auto, but then get a portfolio of autos together that are in and of themselves simple routines, but having the option to run multiple different ones makes you so much more of a alluring alliance partner for the rest of the field that you're competing with.
And your autos will be more consistent.
Yeah. Right after you finish your Kitbot drivetrain and wire it, head over to the field and write your delay, drive forward, and drive backward autos, and then put them on a flash drive.
Yeah. Yes.
Yeah, definitely. So for teams that are a little past the specializing in one game piece, how can teams how do teams go about designing mechanisms to perform the different tasks? Should they try to focus more on one than the other? Should they try to design one that can try to accomplish both tasks? How do teams go about working on these multiple mechanisms and integrating them together? Mike, can you kick us off?
Yeah, so I don't think we're the best at this, but if I had to think about a couple of key factors, when you're looking at your robot architecture, I like to start by using a known quantity base mechanism. So whether that's like a linear elevator, like you see a million different teams using, there's a great product that Adam helps design that does exactly that. Or you have a shoulder pivoting arm. Start with what your base mechanism is going to be, but I like to think about the robot and where you position each of those frame elements and how that factors into the inherent geometry of the scoring elements that you're working with, and try to balance the two of those things together. But I think if there's a lesson that we can learn from other teams, it's 2056 is a great example of this, reducing the number of degrees of freedom that you actually need to complete the task while having mechanisms for multiple scoring tasks is the key factor there. So 2018, 2056's wrist that did not actually reach over their robot and do the slam dunk score, they still managed to get a 3-cube auto, which completely I ruled that out from the start. It's there's no way that's going to be possible. And then 2056 just does it, and it makes it look super easy, right? So I think if you're going to be having multiple scoring objects you interface with, it's all about trying to drive down those degrees of freedom and simplify the execution of those tasks, and try not to complicate it too much.
I would say,
I would rather.
Kickoff. Sorry, go. So Zach.
Sorry. Quick comment. I would rather have 2 independent small degrees of freedom end effectors to accomplish 2 tasks than one overly complicated one to accomplish the same 2 tasks. That's just.
I'd rather have one simple one to accomplish both tasks.
Well, there's some nuance there though. If you're the kind of team that's going to struggle through it, getting something that's integrated is a higher bar. And it's kind of that 2D4 2014 analogy. Once that robot was done, it was incredibly simple. Was it a simple route to get there if you're inexperienced? No way. Like the average team would not have pulled that off for sure. But then once it's finished and you see these excellent people do it, you're like, oh, that's the obvious thing. Everyone should have made this. It's so simple. So, if your team with your most experienced people doesn't see a clear route to making your robot concept, it's probably too complicated. And then there's merit to pursuing the separable design that might be less optimized when you're done. But at least you could have one or the other done versus trying to integrate it and just missing both.
Mm-hmm.
Yep, I agree with that.
Cool. So we have about 5 minutes left. So can each one of you guys just kind of take a minute or so and just kind of sum up, I guess, the key points and key principles that you'd want teams to follow for those that are watching? Hey, Zach, can you kick us off?
Sure. So my main things would be establishing a quality priority list, attacking those priorities one at a time, making sure everybody's having fun, and then you continuously develop those items that you've got.
I think other people are going to have more nuanced points, so I'm gonna stick to the one that I wish pretty much every team was doing, which is building the kit bot. I think Adam mentioned earlier, like no team has ever fallen off our pick list because they built the kit bot, but tons of teams have dropped off our pick list because they built something weird. And man, I'd love to go to a competition and see like 30 kit bots out there because it'd be way more fun of an event. I mean, I don't have any fun when we're working with teams that can't drive around the field or can't play defense. Like that's not a fun experience for, I think, really anybody. So I just love to see more teams like using their resources wisely and building kit bots and then having a good time building scoring mechanisms that are actually effective out in the field rather than spending all their time working on a drive base that's not going to be competitive.
I'd say do less, just in general. There's a lot to that. It's super profound. And then find, those simplicity mentors or simplicity buddies. Mike and Ty have been doing that for me personally for a while. And I can say sincerely, like we would not have won those last 2 world championships if we weren't seeking out and acting on that feedback. It's greatly appreciated. And I wish more teams would do that kind of thing. Like I've never got an email from a team asking me to look at their stuff. And I'm like, I'm not answering this. Those are the best emails to answer, vetting their design and giving them some feedback. So I'm sure there's plenty of people who'd be willing to do it for you. I don't even know which teams I'm talking to. Everyone should be able to find one.
For me, it's take an honest look at what your team's resources are and make sure that whatever concept you're coming up with is within those resources. The biggest mistake that teams can make is overestimating their resources, reaching too far, and then falling flat because of it. At the end of the season, if you build a simple robot and it works really well, then it just gives you more time for driver practice and more time for auto development and more time for all of these things on the back end that most teams struggle with every year. Is they get to events with a single hard-coded auto and then they're really difficult to work with, or they get to an event with no driver practice, and then you spend your 2 districts learning how to drive your robot instead of scoring the district points that are going to get you to the championship. Or if you're not in districts, then not getting you advanced. I don't know.
To expand on Ty's point. Oh, sorry, go.
No, go ahead.
To expand on that, a lot of this is based on self-assessment and how you did last year and that sort of thing. And if you truly did build too simple and you were incredibly ready for every match, you never wasted a second, your drivers are super ready, your autos are perfect, that is the best data point possible for informing what you might be able to do the next year. If you're overcomplicated and your performance is deficient in some way, that's a lot muddier. It's a lot harder to draw clean parallels to what you can actually pull off the next year.
Yeah, for sure.
Absolutely. If there's not any more questions in the chat, I want to thank everyone for joining us today. And I appreciate everyone for giving their thoughts. So
thanks for having
us.
Absolutely.
Yeah, thanks for having us.
Thanks, you too.